starting off Chapter 2 with patterns and inductive reasoning. You're inherently programmed to do this section. Your brain is built to be a pattern recognition machine. It is one of its primary functions. You don't even know it's happening most of the time, but your brain is supremely attuned to noticing patterns. Here's a pattern that they show to kindergartners. Your brain is such a natural pattern recognizer that the yellow square is jarring for most people. It just doesn't fit. Most people don't even need to consciously think about it, but that yellow block is out of place. By all rights, it should be red, if it was going to fit the pattern. Sometimes the pattern is mathematical. You have likely done patterns like this before. It probably didn't take you long to notice the pattern here. Simply add 3 at every step. Now we move on to inductive reasoning, which is a process of noticing a pattern and coming to some sort of conclusion about what you saw. Going back to this pattern again, noticing a pattern is one thing, but inductive reasoning doesn't come into play until you try to decide what you can conclude. Here you take the pattern that you noticed, apply some good old common sense, and come to a conclusion about what comes next. When you come to some sort of conclusion, that is sometimes called a conjecture. In general, with inductive reasoning, you first notice a pattern. Then you use some common sense, if you have any, to come to a conclusion or a conjecture. The conclusion you reach is only probably true. Later we will do deductive reasoning, where the conclusions are definitely true. But for inductive reasoning, it's only probably true. Let's see an example of why it's only probably true. Here's a new sequence of numbers. Which number comes next? What do you think? Easy, right? It's 8. What, 8? I'm sure most of you probably came up with 9 as an answer. At least I would hope you did. But it is 8 here. These are the numbers of the months that have 31 days. January, March, May, July. August is next. That's an 8. Now it's okay that most of you came up with 9. You noticed a pattern, used common sense, and decided 9 was next. But that conjecture was only probably true. That's what this pattern illustrates. Inductive reasoning is only probably true. It isn't definitely true. But inductive reasoning is actually commonly used in real life. In fact, you use it all the time in day-to-day situations. Here's an example from my life. When I was at Deerfield Academy, which is a boarding school in New England, there was a student that really loved his peanut butter and jelly sandwiches. No, I mean he really liked his peanut butter and jelly sandwiches. Deerfield is a boarding school, so students eat at the dining hall for breakfast, lunch, and dinner. And this boy asked if they could put out the PB&J fixings for breakfast too, and not just lunch and dinner. So they obliged, and he started eating a PB&J for breakfast, lunch, and dinner. Every breakfast, lunch, and dinner. It wouldn't be the only thing he would eat, but it would always be somewhere on the plate. Deerfield occasionally has a clam bake which features lobster for everyone. Lobster? Not this guy. Give him a PB&J instead. After this went on for a couple of years, the teachers were sitting around and someone asked if they had ever seen him not have a peanut butter and jelly sandwich, and none of us could. So I used inductive reasoning to conclude that today for dinner, he would come in and grab a peanut butter and jelly sandwich. This is a perfect example of inductive reasoning in real life. We noticed a pattern, namely that this boy ate PB&J for breakfast, lunch, and dinner without fail. We used some common sense about what might come next. Our conjecture was that he would come in and eat another PB&J for dinner today. But our conjecture was only probably true. Yes, he had seemed to do it for a couple of years, but it is certainly possible that today's the day that lightning struck and he decided, you know what? I'm tired of PB&J. Let's go for something new. I told you this boy loved his PB&J. How long could you eat your favorite food for every meal every day? Now people make conjectures all the time. Some of them are fine, and some of them just aren't right. It is often difficult to show a statement is true. However, if you want to disprove it, all you need to do is come up with one counterexample which shows that it isn't correct. Counterexample is a vocabulary word that will come up quite a bit this chapter. Here's an example. Let's say someone came up with this idea that if you're 18 years old, then you can vote for US President. This statement happens to be false. But to prove it false, you need to provide a counterexample where the first part is true, but the conclusion or conjecture just doesn't hold up. Have you come up with a counterexample of your own yet? Here's one possibility. It's false because even though you're 18, you might not be a US citizen. That first part is actually necessary in a good counterexample. You should show that the first part is true, that they are 18 years old, before showing that the right part doesn't work. Here's another possible counterexample. And another one. There are lots of possible answers here. And even though I gave 3 counterexamples here, when you are asked to give one, you only need to provide a single counterexample. One is all you need to get the job done.